Hi class, today we're going to talk about oxidation numbers. This is an important topic for the next set of notes that we're going to talk about, which is balancing redox equations. So make sure you pay attention, that you follow along and you know the rules. To start with, let's talk about what oxidation numbers are. The oxidation number really is just the charge that an atom would have if it was composed of ions. So this can be applied whether or not we're talking about an ionic compound. It's the charge that each atom in that compound would have, the charge that each atom would have. So to start out, we've got some rules for if it is a single element. So substances containing just one element, that's either going to be a monatomic ion, if it's got a charge, or neutral atom or neutral molecule. Okay, so we're talking about just one type of atom. Okay, now if it's a neutral atom or neutral molecule, the charge is going to be 0. Okay, so if you don't see a charge written and it's just one type of element, the charge is always 0, even if it's a diatomic element. If it's a monatomic ion, it's going to be just whatever charge is written. So if I say Fe2+, it's got a 2+ oxidation number. All right, let's go on to the next thing, which is if you have a substance containing multiple elements, we're talking about a compound or a polyatomic ion. So we've got a neutral, compound, or a polyatomic ion. Neutral compounds, the sum of all of the oxidation numbers has to equal 0. They have to add up to be 0 because no charge is written. If it's a polyatomic ion, the sum of all the oxidation numbers need to add up to be the charge of the ion. So if we're talking about sulfate, for example, SO4 -2, the sulfur plus 4 oxygens have to add up to have overall -2 charge. We'll go through examples in a little bit. All right, and then down here, the oxidation numbers, if we're talking about something that is involved in a compound or a polyatomic ion. This whole section down here is based on if it is in a compound or polyatomic ion. Remember, our first rule, if it's an uncombined element, it's going to either be 0 if it's neutral, or it's going to be whatever the charge of our monatomic ion is. But if you've got multiple elements together, it's going to be neutral. It's going to add up to be neutral, or add up to be the charge of the polyatomic ion. So that is the green highlighted area is what we're talking about here, if it's a compound or a polyatomic ion. To start with, you've got these up here. These rules are never violated. Fluoride is always -1 in a compound. Group 1 metals are always +1. Group 2 metals are always +2. So keep in mind, you might write here metals. So if you wanted to write an exception here, you could say H+. Okay, H+ is usually +1, but or hydrogen is usually +1, but there's occasionally a time when it has a different charge. We'll talk about that in a second. Okay, so then we get to the two that are most frequent exceptions, or not necessarily most frequent exceptions, but these do have some exceptions, these two. So hydrogen and oxygen, they're exceptions to their rules, and we've got the exceptions listed on the right. So hydrogen is usually going to be +1. Okay, the only time that it is not +1 is if it violates one of the rules that we wrote up there. Keep that in mind. That's the only time you're going to see it being anything other than +1. And then oxygen is usually -2. The only time that it is going to be anything other than -2 is if it violates something that is above it on the rule list, whether it's hydrogen or fluorine or one of those metals that we talked about above. And pay attention to this note down here. When you're facing difficulties, if you're not sure what to do, always think about the polyatomic ions and balancing the charges of ionic compounds. Okay, think back to when we talked about finding the Roman numeral of a metal, And that's kind of what we're doing here. We're trying to find out what's the charge of each ion.